So our goal today is to take our radical expressions and talk about adding and subtracting with them. So, if we are going to add or subtract, first of all, always, we're going to have to check, hey, are my radicals simplified? Once we have simplified radicals, then we can look for, okay, do we have radicals with the same index? We're going to, because we're only working with square roots. But we need to have the same radicand. That number underneath the radical has to be the same before we can add or subtract. Then what's going to happen is we're going to treat it a lot like combining like terms, okay? As long as we have the same radicand, then we're going to add and subtract the coefficients, keeping the radical the same, okay? For example, if I have 2 square root of 5 plus 7 square root of 5, how many square roots of 5s do we have?
9.
We have 9 square roots of 5, okay? Kind of like 2x plus 7x is 9x, okay? It's that same concept where the radical needs to be the same, and it's going to stay the same when we add and subtract, okay? But some of the trick is going to come in when maybe they're not simplified, okay? So first of all, I want you to just go down to numbers 1 and 2. And I want you to write down what you think the answer is to numbers 1 and 2. And then we'll come back to that example problem. What do you think the answer is for number 1 and number 2? Talk to your neighbor if you need to. Tinley, what do you think about number 1? Like, what would you write down? 1 radical 6?
Yeah.
How do we feel about that? Do we technically have to write the 1 right there? You don't have to write the 1. If you do, it's fine. If you don't, it's perfect. Okay? But 3 minus 2 is 1, so we have 1 radical 6. Okay? Ava, what do you think about this one? Number 2. 4 radical 5. 2 radical 5 plus 2 radical 5 is 4 radical 5. Okay? Now, let's hop back up to this example. The trick is going to be when we don't have a simplified radical, we need to simplify it. Okay? So square root of 20. Can square root of 20 be simplified? Okay. So remember, there's 2 different ways that we can simplify radicals. You can look for the biggest perfect square, or you can make a factor tree. Am I right by making the statement that most of you like the factor trees? Okay. So when I think of 20, I think of 2 times 10, and 10 is 2 times 5. Do I have a perfect square? I have 2 squared, right? So negative 2. And then I'm pulling out the 2 squared, and left over is a 5. So this is how I would show my work. Okay. I then would need to I need to rewrite this first term, if you will. What do I need to rewrite this to be? Okay, this is negative 4 radical 5 minus 2 radical 5. For a total of negative 6 radical 5. You okay? Okay. If you're not sure if a radical is reduced or not, make a factor tree. If you don't have any pairs, we can't simplify it, okay? Sometimes it's obvious, like square root of 7. 7's a prime number. We know that that's simplified, okay? But there might be some other numbers that aren't prime that you're not so sure about. Just try, okay? So in number 3, can we simplify 10 radical 7? No, but I bet we could simplify the square root of 63. What multiplies to be 63? 7 and 9. And I know that 9 is 3 squared. Right? So we have 10 radical 7 plus 2 times that 3 gets to come out of the radical. And 7 remains. So we have 10 radical 7 plus 6 radical 7. For a total of 16 radical 7. Okay, I am going to have you try number 5. Try number 5, see what you get. See if you and your elbow partner can get the same thing.
Wait, 16 and 2.
You can simplify for 1.
You simplify 18, right?
So Joey, is radical 8 all the way simplified? Okay.
Miss, is this right? Like this? Boom, and then that.
So here's the thing. That's 2. That's a 3. Oh, you can't.
I would say that this is not this. Isn't 18, isn't 6 2 times 3?
Oh.
6 isn't even a 6 isn't even
Negative. Okay, so I'm seeing some answers of -1 radical 2. Okay, so when we reduce radical 32, 4 squared gets to come out, right? And 2 stays underneath. When we simplify radical 18, 3 squared gets to come out and 2 stays underneath. So we have 8 radical 2 minus 9 radical 2, which is how we got negative 1 radical 2. Okay. Some of you, I think, need a shot at redemption. So I'm going to give you number 6 as your shot of redemption. What'd you get? 8 radical 7? Couple people at the yellow table got 8 radical 7. How do we feel about that? Yes, and a pass. Okay, so is it true that we have 2 squared trapped under radical 28? So the 2 comes out. And then radical 112, we have essentially 4 squared trapped underneath, right? And so 7 stays under. So we have negative 8 radical 7 plus 16 radical 7. We feel okay about that? I need some like, thank you, okay. Turn to page 8 so we can talk about number 9. In number 9, can any of those be reduced?
Yes.
Which one?
10, 6, and 10.
But can we reduce radical 10? But isn't 10 2 times 5? Okay, is there a perfect square in there? Okay, so we cannot reduce it. Okay, now, are all 3 of those radicals the same? No, we have square root of 10, but then we have square root of 6. That's different. So we can combine the radical 10s together, and we cannot combine the radical 6, so they just have to stay as neighbors. Okay, so the answer I would be looking for is negative 4 radical 10 minus 3 radical 6. Write down your answer for number 10. I don't know what those noises are.
Oh, wait, wait.
But I hope they're helping you think. Rachel, what answer did you write down?
6 radical 7 plus 5.
And how do you feel about Rachel's answer? Okay. Look at that beautiful trapezoid I just drew. All right. Now, notice in number 11, there are 3 different radicals, but we have to reduce some of them. How many of them do we need to work on? Just the first 2. 3 radical 3 we're just going to leave as is. Okay? So I know that 50 is 5 times 10, and 10 is 5 times 2. So what perfect square do we have underneath? Okay, 5 squared is underneath, so I can pull out 5. Okay. All right, radical 18 I know is 9 times 2. And since 9 is 3 times 3, there's our perfect square to take out. I'm thankful that at least 2 of our 3 radicals have the same radicand, right? So I can take negative 15 radical 2 plus 3 radical 2 to get negative 12 radical 2. But then we keep the minus 3 radical 3.